Hello, this tutorial is your first one on polymers, and it's an introduction to different types of polymers, including addition polymers, which you will have seen at GCSE, and condensation polymers, which are new at A level. So first of all, you just need to remember polymers are just long chain molecules formed by the reaction of lots of shorter molecules called monomers, which join together. Okay, so first, just a very brief recap of something that you've met at GCSE, which is addition polymerisation. So this is the reaction where you take alkenes and you react them together, where the double bond breaks and they all join together. So if we start with this molecule ethene, and we start with a number of ethene molecules, so we'll put an N at the beginning to show that we've got a number of them. These can undergo addition polymerisation, where the double bond will break open and they will all join together, so you will end up with something that looks like this. So here I've just shown the beginning of a long chain molecule, which obviously goes off the page, so it's a very, very long chain. There is a simpler way of drawing this, which you should remember from GCSE, which is to draw it like this. So this shows a repeating unit, so the part that's repeating itself, where the double bond used to be. So looking at these parts here, we've got 2 carbons. This would have been the double bond, but in polymerisation it's broken. We've got the 4 hydrogens, so 2 coming off this carbon and 2 coming off this carbon, and then because you've broken this double bond, these electrons can go to form covalent bonds either side, and this unit will repeat itself a number of times, and the number of times is however many alkene molecules you had. So this is the monomer. This is part of the polymer. This is an easier way of drawing the polymer. So this is something you should be familiar with, and you should be able to draw a monomer from a polymer, draw a polymer for a monomer. You should be able to name the monomer, and you should be able to name the polymer. So in this case we have got ethene is the monomer, that's simple, and then because you've polymerised it, it's now called polyethene when it's a polymer. Polyethene we tend to call polythene, so that's plastic like carrier bags. So these sort of polymers tend to be used for various types of plastics. So if you had 3 carbons with a double bond in, propene, you would make polypropene, and that is used to make ropes and plastic bottle lids and things like that. So these tend to be used as plastic. So make sure that you are familiar with that, make sure that you are able to draw these structures and name them, and then we'll look at the new type of polymers, which is condensation polymers. Okay, so this new type of polymer, this is a condensation polymer, and these are formed when you have got compounds that have 2 functional groups on either end of the molecule. So if you take this compound, whatever it may be, with these 2 functional groups, and you line them up together, the functional groups on either end will react with each other to give you one larger functional group. And when that happens, they usually release a small molecule, which is more often than not water. That's where they get their name condensation polymers. So this functional group will join with this functional group, release a molecule of water, and join together. So you can consider condensation polymers to work something like this, where we've got the one molecule, 2 functional groups, another molecule, 2 functional groups, and this will go on and on and on. We'll have many of these. 2 functional groups will combine together, and the same will happen here with the molecule next to it, and the same will happen here to give you a larger functional group, a linking functional group. So here we've got the end of one molecule, new big functional group, the second molecule here, new big functional group, the third molecule here, and they all join in a chain. And every time these two functional groups join together to give you a linked functional group, we release a molecule of water. So if I show you a specific example, which is a polyamide, it'll probably make more sense showing you the actual functional groups that are in place in those molecules. Okay, so to make a polyamide, you start with a dicarboxylic acid, so that's a compound that's got 2 carboxylic acid groups, one on either end, and a diamine, so a compound that has an amine group on one end and an amine group on the other end. And if you line these up alternating, dicarboxylic acid followed by diamine, you will line these functional groups up together, and these will react with each other. So these undergo a condensation reaction where water is released and they form an amide rather than an amine. So this is the sort of product you would get from the reaction of these 2 functional groups here. So I've left the carboxylic acid and the amine, on either end of those two compounds. But in the middle, this carboxylic acid and this amine react together to give you this here, which is an amide link. So an amide is a carbon double bonded to an oxygen in one direction, and then it goes down to what looks like an amine group in the other. So a nitrogen that goes onto another carbon chain with a hydrogen coming off it. You can have this substituted with more alkyl chains if you want to. But this functional group is an amide. And if you've got loads and loads of these compounds together, you will get these two linking up all over the place. So you'll form a really long chain. So you'll get this one linking with the amine of a previous molecule. We've got these two joined together to make an amide here. This amine will link with another carboxylic acid from another molecule to give you another amide there. So you'll end up with these amide links all the way along the chain. So that's the general way that they work. In terms of polyamides specifically, there are two polyamides that you need to know for your exam. You need to be able to show how they're made, write equations for the reaction that produces them. So one is nylon 6,6 and the other is Kevlar. So I'll show you those one at a time, and you need to make sure that you are able to draw them out. Make sure that you know the starting materials for them. Okay, so your first one's nylon 6,6, and the clue is in the name really, the 6,6. So both compounds that you begin with, your dicarboxylic acid and your diamine, have chains of 6 carbons in them. And then obviously one of them's got the 2 carboxylic acids on the end, and one of them's got the 2 amine groups on either end. So these are your two start materials. You've got your dicarboxylic acid with 6 carbons in it, hexane dioic acid, and you've got your amine or diamine with 6 carbons in it, which is 1,6-diaminohexane. And they just do as I showed before, where the amine and the carboxylic acid group bond together to give you an amide link, which will give you the following repeating unit. Okay, so there's your polymer. Now, obviously, if you were drawing this in an exam, you could shorten these bits where you've got loads of CH2 groups by just writing CH2 in brackets and the number of them that you've got in a row in the middle of your formula. That's absolutely fine. But this is the structure of nylon 6,6. So the tricky bit with this is making sure that you know where to cut the compound off, making sure you know at which point do you have the bond that goes outside of the brackets. So my tip for that would be, remember that you're removing a molecule of water. So if you have a look at these two functional groups here, if you consider removing a molecule of water, so if we take the OH from there and an H from there, then you know that when you come to draw your polymer, at the carboxylic acid end, you're going to have the C double bond O, that's fine, but the other bond is going to go off into nowhere, so that's the bond that sticks out. So we've got your C double bond O and your bond that sticks out. And then obviously you can draw the rest of the compound. You can draw your amide link, which we recognise from before, so that's an amide link. Draw the rest of your diamine molecule, and then when we get to the end, according to this, you get to the N, you have one of the hydrogens still on, and the other bond goes out of the brackets. So all the way along, one nitrogen, one hydrogen still attached, and the other bond goes out of the brackets. And don't forget your little N to say that it repeats. So it is knowing whereabout along the chain to stick the bonds that come outside the brackets. But just have a little look, imagine taking out a water molecule and think about where everything would go then. Follow the connectivity of the bonds you've already got. So that is your first polyamide that you need to know about. Nylon 6,6, which starts with hexane dioic acid and 1,6-diaminohexane. 6 carbons in a row here, 6 carbons in a row there. Try and remember it for your exam. And your second one is Kevlar. Okay, so Kevlar is a very strong material used to make bulletproof clothing. And the starting materials for it are benzene 1,4-dicarboxylic acid, which looks like that, and 1,4-diaminobenzene, which looks like that. So again, you have got a dicarboxylic acid and you've got a diamine. You have got an amine group and a carboxylic acid group which can join together to give you an amide link, and that can happen over and over again if you alternate these two compounds and put them next to each other. Okay, so there's your start materials, and joining them together, giving you an amide link, I will show you the repeating unit. Okay, so here on the left you've got a carboxylic acid group, you've got the benzene, and what was another carboxylic acid group, but it's reacted with an amine to give you an amide link. Then we go on to the next benzene ring, and then we've got what was the amine, but obviously that'll go on and form another amide link there. And the same on this side, this carboxylic acid group will go on to form an amide there, and will connect to a nitrogen. So this is the structure of Kevlar. This is the repeating unit, and you need to make sure that you can draw these two starting materials, and you can draw what happens when they undergo condensation polymerization. So make sure you learn that one as well. Okay, so there is one final way of making polyamides, and in this instance you don't need two different molecules because this compound here actually has two different functional groups already. So on the one end it's got an amine group, and on the other end it's got a carboxylic acid group. So these types of compounds are known as amino acids. And because they have these two complementary functional groups, one on either end, if you line these up and make sure that the opposite functional groups are facing each other, you can still get exactly the same thing. You can still get a carboxylic acid reacting with an amine and giving you an amide link. So in this case, an amide link here is known as a peptide link. Okay, so here's the result of what would happen if these two functional groups were to react. So we've still got the amine group on this end. This is now an amide link, and this is carboxylic acid end. Obviously this amine could go on to react with another carboxylic acid part here, and this carboxylic acid could go on to react with another amine part there. So a peptide link is simply an amide link in a condensation polymer, in a polyamide, but it's known as a peptide link when the starting materials were amino acids. So this is how proteins are made. This is the beginning of building of proteins using amino acids. So that's one final way that you can consider to make polyamides. Usually a diamine and a dicarboxylic acid, but in this case you can just use the one compound, which is an amino acid. Okay, so your next type of condensation polymer is not a polyamide, but a polyester, which is obviously something most people have heard of because we use polyester in our fabric, in our clothing. It's a synthetic material we use in place of things like cotton. And a polyester is a polymer that instead of having an amide link in it, it has an ester link. And thinking back, you should know how to form an ester, which two compounds you would need to join together in a condensation reaction to give you an ester. So hopefully you remember you'll need a carboxylic acid and an alcohol. Okay, so here we've got two generic starting materials for making a polyester. So here we've got a dicarboxylic acid, and here we've got a diol. So two alcohol groups, one on either end. And you should recognise this as being able to make an ester link. So a carboxylic acid group reacting with an alcohol group gives you an ester link and releases a molecule of water. So in this reaction of a dicarboxylic acid with a diol, you would make a link that looks like this, and you should recognise this as an ester link. So on the left, I've left the carboxylic acid group, which could obviously go and react with another alcohol group. In the middle, the two functional groups have combined to give you an ester link. Here we've got the rest of the diol, and here on the end we've got the alcohol, which could go on to react with another molecule of the carboxylic acid. So this would form a long chain molecule of alternating parts where this was a dicarboxylic acid, this was a diol, then a dicarboxylic acid, then a diol, and obviously when they combine you'll release quite a lot of water. Now, just as with the polyamides, there is a specific example of a polyester that you need to remember, just the one this time, and it is called terylene. Okay, so terylene, it's also known as PET, which you may see written on some plastic products, particularly Tupperware kind of trays, things like that. Terylene is obviously used as a plastic, and it is formed from the reaction of benzene 1,4-dicarboxylic acid, just like in Kevlar, this time reacting with ethane 1,2-diol. So I'll show you the start materials for that. Okay, so there's your starter materials, benzene 1,4-dicarboxylic acid, as we saw before, and ethane 1,2-diol. And here is where your ester link is going to come in. These two are going to combine, release a molecule of water and form an ester link. So when they join together, I'll show you what the repeating unit will look like. Okay, so here is your polymer. This is terylene. So you have got the part that was in your carboxylic acid here. I've taken off OH on this end and I've taken off H on this end. This gives me the water. so the carboxylic acid part, the benzene part, and what was the other carboxylic acid part, but it is now turned into an ester link. This is the start of what was the alcohol. Then we've got the two CH2 groups from the ethane 1,2-diol, and where we would have had the other alcohol group, we've just got the oxygen, and the hydrogen's gone to make the molecule of water. So terylene, Kevlar, and nylon 6,6 are your three examples that you need to make sure you know. You need to know the starting materials, and you need to know how to draw the polymer. Okay, and I'm going to leave it there for your introduction to polymerisation. So I've reminded you of addition polymerisation. You need to make sure that you know it. I've shown you two different types of condensation polymer, a polyamide and a polyester. Polyamides can be formed from dicarboxylic acids and diamines, or they could be formed from amino acids joining together. I've also shown you polyesters, which require a dicarboxylic acid and a diol. I've covered your three different types of polymer that you need to know inside out, which are nylon 6,6, Kevlar, and terylene. In the next tutorial, I will look at the hydrolysis of polymers, look at the properties of polymers and link that to the hydrogen bonding between the chains, and we will look at a little bit more at being able to draw monomers, draw polymers, and draw some repeating units. So that's all for now, and thank you for watching.